So here's number 2.
Number 2 says, Michaela is using the following information to prove that angle TUS and PUQ are complementary angles in the diagram shown. Part of her proof is shown below. It says, given the ray US
Bisects angle TUR. So this ray US bisects angle TUR. And ray UQ bisects angle PUR. So UQ bisects PUR. And then we have a 2-column proof.
Which statements could be used to complete Michaela's proof? So the answer is D. And let's see why. So remember that we're trying to prove that TUS and PUQ are complementary, which means that they have to add up to 180 degrees. Now, if you look at options A and C, they don't even mention that. Options B and D, at least statement 5 says that the two angles add up to 90. And then you can see in the proof that in line 6, immediately after that, they're using the definition of complementary angles to say that they're complementary. So really in statement 5, we need to say that the two angles add up to 90. So that leaves us between options B and D. Now, the reason it's option D is because
you can use algebra to go from statement 4 to statement 5. So from statement 4 to statement 5, so we have 2 times the measure of angle TUS plus 2 times the measure of angle PUQ is equal to 180. So if you divide both sides of the equation by 2, so we're going to divide this entire side by 2 and this side by 2, then what happens is this 2, all 3 of these 2's cancel out, and we're left with everything else in the numerator, which is measure of angle TUS plus measure of angle PUQ equals to 180 divided by 2, which is 90. And this is literally what we want to say, and that's what it says in statement 5. That's what it says right there in statement 5. So it's because of division property of equality
that we can conclude statement 5. So the answer is D. Okay, let's go to number 3. Number 3 says, in the figure shown, line CF intersects line AD and EH at points B and F respectively.
So we have these 2 lines that seem to be parallel, but they haven't told us that yet. So we can't assume it. Being intersected by this transversal
CF. It says, given angle CBD is congruent to BFE. So they're telling us that
this angle is congruent to BFE, which is this one.
Again, they look like corresponding angles, but they never told us that the lines are parallel. So we're probably not going to be able to use that fact. And then it asks us to prove that ABF is congruent to BFE.
So let's highlight those in a different color. ABF, which is this angle. They want us to prove that's congruent to BFE. This angle right here, which we had already marked in blue earlier.
Okay, so this is a very short proof. There's only 3 lines. So the first line says that angle CBD is congruent to BFE. That was given. So that's this choice down here, given. The next line says CBD is congruent to ABF. CBD is congruent to ABF.
So how can we know that this blue angle right here is congruent to this green angle right here? That's the vertical angles theorem. So this is vertical angles.
And then the last choice, there's only one option left. It's substitution and transitivity. So
this is substitution slash transitivity of congruence.
And the reason is because notice at this line, the first line of the proof right here, I'm squaring in blue, it says CBD is congruent to BFE. But on the next line, we know that CBD is the same thing as ABF. So where we saw CBD before, we could just substitute ABF. And that's exactly what happens. Like, this first line is pretty much the same as this one. Notice that they both have BFE on the right-hand side. But then what happens is that we exchange the ABF for CBD. So this is just substitution, or transitive property of congruence. Okay, let's go to the next one.
Question 4.
It says, in the figure shown, line CF intersects AD and EH at points B and F respectively. So this is the same setup as the previous question. And here it says measure of angle CBD is equal to measure of angle BFE. So
It starts off exactly the same. So this angle is the same as this one.
here it wants us to prove that measure of angle BFE plus measure of angle DBF is 180. Measure of angle
BFE, so let's mark these two in red. BFE is this same angle, which we had already identified, plus DBF, which is this one. Now, if they had told us that these two lines were parallel, then we would just say, yeah, of course they add up to 180 because they're consecutive interior angles. But they didn't tell us that the two lines are parallel, so we're going to have to prove it by other means. So let's erase that.
Alright, so let's look at the first line. The first line says measure angle CBD is equal to measure of angle BFE. That was given. The next, so we can cross out this. The next line in the proof says that measure of angle CBD plus measure of angle DBF. So CBD is this red one that we marked. Oh, sorry, that's not that one. CBD is this blue one that we marked, plus measure of angle DBF. That's this red one. And they're saying that that adds up to 180. And that's true because they form a linear pair. The two of them combined form a straight angle. So that is, linear pairs are supplementary.
So that goes here.
And then the last one says measure of angle BFE plus measure of angle DBF is 180. So this statement looks pretty much exactly the same as this one, except that BFE got substituted for CBD, and we're allowed to do that because in the first line up here they told us that they're congruent to each other. So this is just substitution. Okay, next question. Question 5. Which of the following sets of lengths can form the sides of a triangle? Choose all that apply. So here they're testing you on whether you remember the triangle inequality. The triangle inequality said that
The two smallest sides, so let's say you have three sides, A, B, C, and let's say that A is the smallest one, so A is less than B, and B is less than C. This statement right here just basically implies that C is the biggest one. Alright, so the triangle inequality said if you have three sides, A, B, C, and C being the biggest, then what needs to be true is that the sum of the two smaller ones, so A plus B, that has to be bigger than C. That was the triangle inequality. And then what I had done that day when I showed it to you was I had like a straight line like this, I had another partial line segment like this, and another one like this.
And I said that if you try to open up the red and the blue one to try to actually create a triangle, you wouldn't be able to because they're too short. They have to be longer than the black line.
But in this little diagram, they're the same length.
Okay, so we're basically looking to see for which of these options do we have this property, which is that the two smaller sides have to be bigger than the third one.
Okay, so let's look at option A. Option A says 5, 9, and 7. The two smaller sides would be 5 and 7, and we have to ask whether 5 plus 7 is bigger than the remaining side, 9. So is 5 plus 7 bigger than 9? The answer is yes, it is. So this could actually be a triangle. This works. Option A works. Let's look at option B. Option B says 4, 8, and 3. We're going to take the two smaller ones, which is 4 and 3. When you add those together, 4 plus 3, is that greater than the remaining side, which is 8?
The answer is no, it's not, because this would be 7, which is actually less than 8. So that doesn't work. So option B does not work. Option C, again, the two smaller sides are 11 and 11. Unfortunately, 11 plus 11 adds up to exactly 22. So 11 plus 11 is not bigger than 22. It adds up exactly to it. So this won't work. That would kind of be like this situation right here on the bottom right. You wouldn't be able to move those lines up to make a triangle. Alright, option D says 2, 5, and 4. The two smaller ones are 2 and 4. Is 2 plus 4 greater than the remaining side 5? The answer is yes, it is. So this would work. E says 7, 9, and 12. The two smaller sides are 7 and 9. That adds up to 16, which is greater than 12, so this works. So this would be a good triangle. And then the last one is 10, 8, and 2. The two smaller sides are 8 and 2, and that adds up exactly to 10. 8 plus 2 is exactly 10, which means that it's not bigger than 10. So this wouldn't work. So the answers are A, D, and E, according to the order that my choices are in. All right, question 6. Question 6. In the diagram below of triangle ABC, AC extends through point C all the way to point D. So they're just saying that this line was extended all the way to point D. And BE is drawn to AC. And then they draw this point in the middle here. This line segment. Okay, and they're asking us which of the following is true. Okay, so the answer turns out to be D, so let's explain that. The reason it's D is because it's saying measure of angle 7 is equal to measure of angle 3 plus measure of angle 2. Okay, so we're looking at 7, and the claim is that it's equal to 3 plus 2. Okay, so the key here is to look at angle 4. So angle 4 angle 4 is supplementary with angles 3 and 2. Now, why is that? That's because the 3 angles in that triangle, they have to add up to 180. So these 3 angles, they have to add up to 180. So angle 4 is supplementary with both of them combined. Okay. On the other hand, angle 4 is also supplementary with angle 7. The reason being because if you take the two combined, angles 4 and angle 7, they form a straight angle. So we got this angle 4 that is supplementary with this pair that I'm circling in purple, but it's also supplementary with angle 7. And we've used this logic a couple times before. If an angle, in this case angle 4, is supplementary with two different angles, then that means that the two different angles are congruent to each other. So like whatever the number is that makes 7 supplementary with 4, 2 and 3 have to have that same number, like added together. They have to be that same number added together. So that's why it's D. A simplified version of this fact looks like this. You just draw a triangle, and if you extend one of the sides, then this red angle right here has to be equal to the sum of these two blue angles. Okay, and the reason is this sort of substitution argument, which is that this black angle right here is supplementary with both of these, but at the same time it's supplementary with this red one. Therefore the red one and the two blue ones have to be the same amount. Okay. Let's do number 6. So number 6, I'm gonna have to omit from the assignment because there was no drawing. But I remember what the drawing is, so I'll go ahead and draw it here anyways, just so we can do it. So you guys can get the exposure to the question. Okay, so the drawing was something like this. Let's see, it was AOB was the original angle. Which of the following statements must always be true in the construction of the angle bisector? So this is AOB. And then P, which is the other letter that pops up over here on the left, is actually the point at which your markings will meet to create the angle bisector. So this is so the angle bisector is going to look like this. And then they're asking you what has to be true, which of these lengths have to be the same. Now remember how you would actually find this point P. The way you would find that is you would put your compass down at A and then draw a circle that intersects P, and you would put your compass down at B and you would draw another circle that intersects there. That's how you would get that point of intersection and be able to draw the point P. And furthermore, these two circles the circle that you were making here and the circle you were making here, they have to have the same radius. Okay, so that's an important part to filling in the table at the left. So let's look at the first row. The first row says that OA is equal to OB. Is it true that OA has to be equal to OB? And the answer is yes. OA has to be equal to OB. That has to be true, because if you remember, the first step in creating an angle bisector is you put the compass down at the vertex of the angle and you draw a circle that intersects both sides of the angle. And since it's the same circle, the radius from here to here has to be the same as the radius from here to here. Okay, so that's why OA and OB have to be congruent to each other. So this is correct, that has to be true. The next one is that AP has to be congruent to BP. So they're saying that this distance has to be the same as this distance. And that's what I alluded to earlier, is the fact that we're purposely drawing these circles the same size. So this circle in green has to be the same as this circle in green. Okay, so then of course this being a radius of that circle and this also being a radius of the circle means that they have to be congruent. Okay. Okay, so AP is congruent to BP, that's true. AB is congruent to BP. So they're saying that this line segment from A to B has to be congruent to the line segment from B to P. That's not true. That's pretty obvious visually. So we can put that's incorrect over here. And then OB is equal to BP. So they're saying that OB, this line segment, has to be equal to this one. Now that's not true. That doesn't have to be the case. Now the way that we always drew them on IXL, it turned out that that would be true. But the circle that you use at the beginning, so let me clear up this drawing a little bit. So the circle that you would use centered at O that goes through B and A, it doesn't have to be the same circles that you use here. If they were, then yeah. Then, you know, this radius here would be the same thing as this radius along here. But you don't have to do that. Although those were the steps that we used on IXL, but you don't have to. We kind of learned something similar when we did some of the other Edulastics, where there was this question that asked about how big does the compass setting have to be? Like if you have, I think the letters were T and W, and they asked how big does the compass setting have to be? And the thing to notice was that it had to be bigger than halfway. Like the circle you drew had to come out at least out to there. And then you would do the same size circle over here. And one of the things that we realized when we did that example is that on IXL, we always took the circles all the way out the entire length of TW. But we found out that we don't actually have to do that. As long as we go past halfway, that's good enough. Okay, so it's kind of similar with this with this statement here, claiming that OB has to be the same as BP. They don't actually have to. You don't actually have to use the same exact circle that you use in the first step, and it'll still work. Okay, so this is a no. All right, and then OA is equal to BP. So they're saying that this radius, or this length, has to be the same as BP. That does not have to be true, for the same reasoning as the previous one. This distance, this radius, is created from the first circle, and then this distance from B to P, that's created with a second circle. That doesn't have to be the same size. Okay, so this is, no. Okay. So those are the answers for that one. Okay, let's look at the next question. I think I can fit all of these on the same. So let's try to do that. So let's erase this. And erase this. And this. Okay, so number 8. Number 8 says, what is the equation of the line through 3, 7 that is perpendicular to the line through points -1, -2, and 5, 3? So we want to know the equation of the line that goes through 3, 7. Okay, now if you remember from previous questions like this, we need two things. We need to know the slope of our line. All right, so we have our line is going to be y equals mx plus b. We need to find the slope. And then we need a point that the line is on so that we can figure out what b is. Now, we already have the point that our line is on. It's 3, 7. What we don't have is the slope. But when you continue reading, it says that the slope of our line is perpendicular to the line that goes through these 2 points. So if we could figure out the slope of the line that goes through these 2 points, then we'll just do the negative reciprocal to figure out what the slope of our line is, since our line is perpendicular to it. Okay, so we could figure out the slope of this line, by the line that goes through these 2 points by using the slope formula. So we can do slope is equal to y2 minus y1 over x2 minus x1. So when we plug that in, we get 3 minus -2, which is actually 3 plus 2, which is 5. And we get 5 minus -1, which is actually 5 plus 1, which is 6. So we get 5 over 6. That's the slope of the given line. Our line has negative reciprocal slope. So let's do that in a different color. The slope of our line is -6 over 5. Okay, so we can update our equation. Over here we can say that y equals -6 over 5 times x plus b. And now one way to find b, which is the last thing we need, is to plug in the coordinates of the point that our line passes through. So we're going to go ahead and we're going to take this 3 and 7, they're x and y, we're going to plug them into our equation. Let's bring that work up here. So 7 is equal to -6/5 times x is 3 and then plus b. Okay, so we have to be able to calculate -6/5 times 3. Unfortunately, that is not very nice. It's -18/5 plus b. So if we want to undo the -18/5, we have to add -18/5. So we're going to add 18/5, add 18/5 over here. So one way to do that is So I'm just going to show the work for that here. So the last line is going to be b equals something. And I'll just show the work for that right here on the right in black. So we basically have to add 7 plus 18/5. So if I get them both in the same denominator, we're going to have 35/5 plus 18/5 is equal to 53/5. So that should be good enough, 53/5. If you wanted to change it to a mixed number, that would be 10 3/5, or even a decimal would be 10.6. So that's what B is, 10.6. And now we can go ahead and plug that into our final answer. So when we finally update the full equation, we have, I'm just going to write it in the box that's given. Y equals -6/5 x plus 10.6. So that's number 8. All right, number 9. What is the equation of the line through 3, 7 that is perpendicular to the point? That's the exact same question. Okay, sweet. So we don't have to do that one. Number 10. Create the equation of a line that is perpendicular to 2y equals 14 plus 2/3 x and passes through the point -2, 8. Okay, so we can't easily identify what the slope is here because it's not in slope-intercept form, but we can change it into slope-intercept form. So let's start doing that on the left over here. So we got 2y equals 14 plus 2/3 x. I'm going to switch the order of these two. Not a big step, but that's what we're used to when we say y equals mx plus b. So now we got the x term first. Okay, now we're going to divide both sides by 2. So we get y equals, this is going to be 2/6 x plus 7, which simplifies even further to 1/3 x plus 7. Okay, so how did I get 2/6 there? So remember, the operation is 2/3 divided by 2, but I don't want to write it like that. Let's use the little division symbol from elementary school. So 2/3 divided by 2. Now that's the same thing as 2/3 divided by 2/1. And then finally, the way that you do division of fractions is that you have to multiply instead by the reciprocal. And then this gives us 2 times 1 at the top is 2, and 3 times 2 on the bottom is 6. That's how we got 2/6 over here on the left. Okay, so let me erase all that, just you guys can see how it worked, how I got 2/6. And then that simplifies to 1/3. Okay, so that's the equation of the given line, but just rearranged so that it's in the slope-intercept form. And now we can easily read what the slope is. The slope is 1/3. Okay, and it says that our line, the one that we want to create, is perpendicular. So that means that the slope of our line has to be the negative reciprocal of 1/3. So it's going to be 3/1 and negative, which is just -3. Okay, so we have the slope, and we also know one of the points that our line passes through. So let's go ahead and update our equation. Y equals m is -3 x plus b. And we could solve for b just by plugging in the coordinates of this point that we were told lies on our new line. So let's go ahead and plug in -2 in for x and 8 for y. So that's going to be, it's going to look like this. 8 equals -3 times -2 plus b Okay, lucky for us, we don't have fractions here. 8 is equal to 6 plus b, and then we're going to subtract 6, subtract 6. This cancels out, and we're left with b equals 2. Okay, so then we can finally update our equation, so we have y equals negative 3x plus 2, and that'll be the final answer. Okay, that's all for part 2 of the solutions.